Let's construct a truth table for a statement with a conjunction and or a negation. What are these words and how do we use them? What do they mean? What do they mean? Well, a conjunction is an and statement, right? I need peanut butter and jelly on my sandwich. P and Q. Symbolically, I like to think of this as an A, except we're missing that slash in the middle. So P and Q. Now for a conjunction, both of these statements, both P and Q must be true for the entire conjunction to be true. If either one of these is false, either P or Q or both, then the entire thing is false. For a negation, we are talking about the opposite truth value. So if I'm giving you P, and let's just say that P is true, then not P, shown by the squiggle, would be false, right? They're opposite truth values. Okay, great. Now that we know what they are, let's play. Let us construct a truth table for not P and Q. Okay, so remember, when we're figuring out a truth table, we start with 2 and then say, okay, I have 2 statements, so I put a 2 as the exponent for the 2 statements, so I have 4 lines. So I have P and Q. The first one, I take those 4 lines and I make the first 2 true, the second true, false. You always split it in half. If you start with 4, then the first 2, right, 2 and 2. For my Q, I'm going to go true, false, true, false. So you kind of break it in half. You go 2 by 2 in the first one, 1 by 1 in the second. Now you'll notice that we have a not P. So anytime you have a negation, you want to start with that. Now recall that a negation is the opposite truth value. So I look at P. P is true, true, false, false. So what's the opposite of that? Well, false, false, true, true. And now I've negated P. So when I go in to say, okay, not P and Q. Well, I'm looking at my not P and Q column. I'm comparing those two. Remember that and, the conjunction. I need both of them to be true. So I have false, true. Well, that's false. False, false. Also false. True, true. There we go. And true, false. So there is my truth table for not P and Q. Let's extend this. Okay, so we just did not P and Q. But what if I want to extend it to include P and not Q? Okay, we can do this. Let's think through. So I'm going to take and I'm first going to put a not Q column. And I'm just going to put it right here on this one. So not Q. So instead of it being true, false, we're going to have false, true, true. Okay. Okay, so we negated Q. What else do we have? So now we need, wrong button. So now we need P and not Q. So P and not Q. So I'm going to use the P column and the not Q column. Compare those. And remember, we are dealing with the conjunction, so they both must be true. Okay, so true, false, that's false. True, true, that's true. False, false is false. False, true is false. Okay, so we now have this side done and that side done, and now we're joining them with a conjunction. So in our last spot here, we'll have not P and Q and P and not Q. So our two big columns, let's compare them. And because they are joined by the conjunction, both must be true for this conjunction to be true. So I have false, false, that's false. False, true, also false. True, false, also false. And false, false, also false. There is no time when the conjunction not P and Q and P and not Q, there is no time when it's true, right? It is always false, which happens, right? That totally happens. Okay. Let's do a different type of an example here. So using the truth table created, we're going to kind of create our own line. Consider the two statements. P is 3 plus 2 is less than 1 plus 4, and Q is 2 times 3 is less than 9 times 1. What is the truth value of negative P and Q? Okay, well, let's just think about P here. 3 plus 2 is 5. Is that greater than 1 plus 4, which is also 5? Is 5 greater than 5? No. So P is false. Q, 2 times 3 is 6. Is 6 less than 9 times 1, which is 9? Yes. So Q is true. So if I'm thinking about P and Q, I know that P is false, Q is true. Okay, well, we're comparing not P and Q. So if I go and say, okay, well, I need not P. Oops, that should be a P, not P. So here, P is false, so not P would be true. So then if I want not P and Q, and means they both must be true. So when I compare not P and Q, true, true, it is true. So the truth value of not P and Q is true. So just a little playing with conjunctions, negations, and truth tables.